All right, let's take a look at these. So on this first problem, they've said they want you to find the scale factor between each pair of shapes. That is, what are the sides of the each original shape multiplied by to get the new shape? So from the original to the new, what do we have to multiply by on this one? 1/2. So the scale factor is 1/2 on this one. What about 4b? What is the scale factor here?
5/4.
Yeah, it's 5/4. Was it quite as immediately obvious? No. Now, for this, when we're doing the scale factor, we can take the new over the original and just reduce it. Or 3/6 is 1/2. We can always do that to find the scale factor if we know that the two figures are similar. And then it's the same thing here. It's just 5 divided by 4. So if you take a new side divided by the corresponding original side, that will give you the scale factor every single time. Okay? So we already answered the question. It was easier to do it probably for A. It's just kind of obvious. So let's take a look at this one. A study team was working together to find the scale factor for the two similar triangles showed it right. Claudia set up a ratio of 14:4 to find the scale factor. Isaac set up a ratio of 28:8 to find the scale factor. And Paula set up a ratio of 21:6 to find the scale factor. What did the students do the same when they found their scale factors? What did they do differently? So what was the same? Say it again. I'm sorry, I missed the first part. And which one did they put on the top every time? Yeah, they always put the new over the original. So it's always the new side over the original side. What was different? Well, they just picked different sides to work with, right? So then the question becomes, well, do similar triangles have more than one scale factor then? Do they? Most decidedly no. Yeah, when you reduce these, so we're on the front right now. Why you would be on the back, I have no idea. But we're on the front. 14:4, both of those are divisible by 2. That's 7:2. 28:8, both of those are divisible by 4, and that's 7:2. And 21:6, both of those are divisible by 3, and that's 7:2. So why does it make sense that the ratios are all equal? Because if the ratios are not equal, the triangles wouldn't be the same shape. All right. If the scale factor is different, then we're going to start changing the angles, aren't we? All right. Well, now on to the back. So Alex was working with the two triangles from problem number 1, but now he has a few more pieces of information about the sides. He has represented the new information and his scale factor in the diagram shown at the right. So he found that the scale factor is 5/4. So to get from the original to the new, we need to multiply by 5/4. And he's written that right here. Personally, on this one, I don't like to do the dot multiply because it's too easy to lose it. I like to write, times like that instead of the dot. So use the scale factor to find the length of the side labeled x. So we're going to go from the original to the new. So we're going to take 6 times 5/4. Well, 6 times 5 is 30. That would be 30 over 4, which is 15 over 2, which is 7.5. And that's going to be x. And this is how you would show your work. All right, since Alex multiplied side lengths of triangle G to get triangle H, he needs to undo the enlargement to get the side labeled Y. So we're now going this direction. What operation would he do to undo the enlargement? Yeah. He would need to divide by 5/4. So that's going to be H divided by 5/4 is going to give us G. So let's find Y. So we're going to do 10 divided by 4/5 to find Y. When you divide by a fraction, it's the same as multiplying by the reciprocal. So this would be 40 over 5 is 8 inches for Y. Now, what if H had been the original triangle and G had been the new triangle? How would the scale factor change? How would the scale factor change if H was the original and G was the new? Yeah. It'd be 4/5 instead of 5/4, which is the, it's the reciprocal. So it would be the reciprocal. Four-fifths. Because dividing by 5/4 is the same as multiplying by 4/5. All right, so for the pairs of similar shapes below, we want to find the lengths of the missing sides. Be sure to show your calculation. You can choose which shape is new and which shape is original in each pair. It doesn't make any difference. Some people like to put the small one always on top and the big one always on bottom because it feels like it's, people don't like it because they're like, it's an improper fraction. They don't like that. That's fine. So if we make this one the new and this one the original, if we take the new over the original, so that would be 11 over 33. So the scale factor would be 11 over 33, which is 1/3. So then to get x, we would take the 39 times 1/3. That's 39 over 3, and that would be 13 centimeters. And for the y, we would need to take 9 and divide by 1/3, which is the same thing as multiplying by 3. So that would be 27 centimeters. This is how you should show your work. Tell what it is that you're finding, show what operation you're going to do, and then do the operation. This should not be in the margins any place. This should not be off to the side someplace. It should be clearly labeled exactly like this. All right, please go ahead and do B, C, and D. Once you're done with them, check with someone nearby you to see if they agree with you or not. If not, arm wrestle mentally. Bless you. So again, once you're done, check with somebody nearby you. Make sure that you agree with their answers and they agree with your answers. Because in just a moment, I'm going to start calling on people, and you're going to have to tell me not just what did you get, but how did you get it? Again, you want to make sure you have checked with somebody nearby you that your answer and the method that you use to find it are correct. All right, by a quick show of hands, how many of you need a little bit more time? Okay, that's fine. All right. So I'll call on someone. My magic number generator generated several different numbers. Some of them were desks where people aren't here. In that case, I'll answer it. So for BX, desk number 12, tell me, what was your expression, and then what is your answer?
X equals 6 times 8 thirds, which is 48 over 3, which is 16.
Great, except for one minor thing at the end. Make sure to give units if units were given in the problem.
Okay.
So it should be 16 inches. Very nice.
Sorry.
No. You aren't the only one by any stretch of the imagination. Then for Y, that's desk 3. The one sits there, so I'll tell you that that's just 9 inches. This is a parallelogram, and so the opposite sides are the same. There's no calculation that has to be done on that one. It's nice that it worked out that it was one where I didn't have to do anything. All right, and then for C, for X, we want desk 10, but Bella's not here at the moment, so I will tell you that I wrote down X equals 17.5 times 2/5, which is equal to 35 fifths, which is equal to 7 meters. All right, then for Y, desk 5, that would be Paul. For Y on C.
I got 35 over 14 divided by 25 over 1.
Whoa. You got what now?
Y equals 35 over 14 divided by 25.
Oh, so when you did the 35 over 14, you didn't simplify that. If you 35 over 14, I was wondering why it was taking so long. Always simplify your scale factor. 35 over 14 reduces to 5 over 2. That'd make it a lot easier. So anyway, what did you end up with?
For my answer?
Yeah, Yeah, 10 meters. It'll just be easier if you'll reduce your scale factor. Okay. All right, and then let's see. Johnny, Z.
20 meters.
How? What's your expression?
Um, 8 times 2.5.
Okay. And how'd you get 2.5?
I divided 25 meters by 10 meters.
Okay. And you get 2.5. That absolutely works. Good. All right, desk 7. Give us X for the next one. How did you set it up?
I'm trying to find it. I did 6 times 1.5, which equals 9.
So,
I got
oh, okay.
I got 1.5 from dividing 6 by 4.
Hang on a second. I wrote it wrong on mine. So X should be 9 feet.
Yes.
Good. All right. Then Cooper, tell us how to set up to find Y.
I did 12 divided by 1.5, which came out to be 8 for Y.
Okay. Yeah, it's going to be 8 feet, right?
Yes, sir.
Good. And then desk number 11.
Yes, sir.
Ben,
4.
Z on the last one.
Z on B. So I took 5.7 and I multiplied it by 2/3,
Mm-hmm.
and I got 3.8 centimeters.
Centimeters?
Not centimeters, sorry, feet.
There we go.
Yep, centimeters.
3.8 feet. Good. All right. Any questions about that? Okay. Then that's it for today's lesson.